In 1953, Sir Edmund Hillary and Tenzing Norgay stood atop Mount Everest, the highest point on Earth, gazing out over the world below. Fast forward to today, humanity sets its sights on an even greater challenge: Mars, a planet 140 million miles away. What drives us to conquer such impossible frontiers? Is it sheer curiosity, the thirst for glory, or something deeper? Perhaps a survival instinct embedded in our DNA. Let's unravel the story of human exploration, from the icy peaks of Everest to the red deserts of Mars. Why do we explore? This question has haunted humanity for centuries. Whether it's the towering peaks of the Himalayas or the vast expanse of space, our desire to push boundaries seems insatiable. In the early 20th century, Mount Everest was as alien to explorers as Mars is to us today. It was a place of mystery, danger, and awe, a third pole that seemed unreachable. Similarly, Mars today represents a new Everest, a symbol of our relentless drive to go beyond. But here's the twist. Climbing Everest and reaching Mars are not just feats of physical endurance. They are technological revolutions. The tools that took Hillary and Norgay to the summit were primitive compared to today's gear. Likewise, the Apollo missions that took humans to the moon were rudimentary compared to the spacecraft being designed for Mars. How far can technology take us? And at what cost? In 1924, George Mallory famously replied, "Because it's there," when asked why he wanted to climb Everest. But what does "there" really mean? For early climbers, Everest was a test of human limits, a place where survival was uncertain and death was almost guaranteed. Before satellite imaging or GPS, climbers relied on crude maps and sheer determination. The first successful ascent in 1953 marked not just a triumph for mountaineering, but also a moment when humanity realized it could conquer nature's most formidable challenges. However, Everest wasn't just about glory. It was also about science, understanding high-altitude physiology and weather patterns. Similarly, Mars isn't just about planting flags. It's about unlocking secrets of geology, climate, and perhaps even life itself. Mars is often called Earth's twin, but nothing could be further from the truth. While Everest is 8,849 meters tall, Olympus Mons on Mars dwarfs it at 21.9 kilometers, nearly 3 times higher. Yet height isn't the only challenge. Distance is. While Everest is accessible within days by helicopter or foot, Mars lies millions of kilometers away. At its closest approach, it takes light itself over 3 minutes to travel between Earth and Mars. The challenges don't stop there. Cosmic radiation. Unlike Everest's icy winds, astronauts on Mars will face deadly radiation. Isolation. A climber on Everest can call for rescue. An astronaut on Mars is utterly alone. Survival. On Everest, oxygen tanks are optional. On Mars, they're mandatory. Does this make Mars exploration impossible? Not at all. It makes it inevitable. When Hillary climbed Everest, he carried basic tools: ropes, ice axes, and oxygen tanks. Today's climbers use GPS trackers and ultralight gear. Similarly, early space missions relied on analog computers and manual controls. Now we have AI-driven rovers like Perseverance exploring Martian terrain. Consider this. NASA's Artemis program aims to return humans to the moon as a stepping stone for Mars exploration. Why? Because every great journey needs a base camp. Just as climbers acclimatize at Everest Base Camp before ascending higher altitudes, astronauts will use lunar bases to prepare for longer missions. But here's a provocative question. Should we invest billions in space exploration when Earth faces so many crises? Or is space exploration precisely what will save us, by driving innovation in energy, material science, and even climate solutions. If Mount Everest is humanity's ultimate terrestrial challenge, Olympus Mons is its Martian counterpart, standing at 21.9 kilometers tall with a base spanning Arizona's size. Olympus Mons represents both an opportunity and a mystery. Why did this volcano grow so large? Could its ancient lava flows harbor signs of life? And will future explorers dare to climb its slopes? Unlike Everest's tectonic origins, Olympus Mons owes its size to Mars' lack of plate tectonics. Lava erupted in one spot for billions of years without interruption, a geological marvel that offers clues about planetary evolution. Imagine standing atop Olympus Mons one day, no oxygen mask needed, thanks to pressurized suits, gazing at a horizon that stretches farther than any view on Earth. What connects Hillary's ascent with NASA's ambitions? It's not just technology, it's resilience. Both mountaineers and astronauts face near-certain failure, yet press on. As Elon Musk once said about Mars exploration, a bunch of people will probably die in the beginning. But isn't that true of all exploration? Mallory died attempting Everest. Countless sailors perished seeking new continents. Yet humanity never stopped exploring. Here's where things get philosophical. What happens after we conquer these frontiers? Will we terraform Mars into a second Earth? Will climbing Olympus Mons become as routine as scaling Kilimanjaro? Or will we look even further to Europa's icy oceans or Titan's methane lakes? If history teaches us anything, it's this: every summit conquered reveals another peak beyond it. So ask yourself, are we explorers because we must be, or because we choose to be? From the frozen slopes of Everest to the dusty plains of Mars, humanity's journey has always been one of discovery and defiance. We've gone from asking why climb to why explore. The answers may differ, but the spirit remains unchanged. As you watch this video today in 2025, remember this moment, not as an end, but as a beginning. Whether it's standing atop Olympus Mons or sailing past Pluto one day, our greatest adventures still lie ahead. And who knows, maybe one day you'll be part of them. Don't forget to like and subscribe channel. See you in next video.